Lesson 10.3 is on operations with radical expressions. So if we look at page 626, kind of the gist of what we're doing here, it's similar to what we've done with combining like terms. So for example, in the past you've done something like 6x plus 9x. We can combine and get 15x. That's pretty much the same idea as what's going on in problem 1 part A, where we have 6 square root of 11 plus 9 square root of 11. Since these are both being multiplied by square root of 11, it's the same idea as what we just did with the x's. So we can just add those together, and that would be 15 times the square root of 11. On part B, it's the same idea. Square root of 3, this first one, there's not a number in front of it. We can put a 1 there, and then if you want to add the opposite, you can. And then since both of these are something times the square root of 3, this is kind of like if we had 1x minus 5x. All right, so if you did that and you'd get negative 4x, it's the same idea, except instead of an x, we have a square root of 3 here. So that would come out as negative 4 times the square root of 3. So if we look at the got it 1, part A, same idea. If you'd like to add the opposite there, you can. Those both are like terms that we can combine together. So this would be negative 1 times the square root of 2, or you can just list it as negative square root of 2. Both of those are equivalent answers. For part B, you add those together, would be 7 times the square root of 5. Sometimes when you're doing problems, it might look like there's nothing you can do, but in those cases, sometimes you can simplify first and then you'll be able to work these out. Kind of like with fractions, you know, sometimes you look at fractions and think, oh, I'm going to have to do something else before I can combine. It's kind of a similar situation. So problem 2, they want a simplified form of this. So at first glance you say, well, square root of 3, square root of 12, there's nothing we can do. But square root of 12, we can break that down. Square root of 4 times the square root of 3. Square root of 4 is a perfect square. So square root of 4 is 2. So that gets us to a point now where we have two things with square root of 3. So 5 square roots of 3 minus 2 square roots of 3 leaves us 3 square roots of 3. Kind of like 5x minus 2x is 3x. So if you look at the got it 2 part A, simplified form there. Square root of 28 we can do as 4 times 7. Square root of 4 times square root of 7. And then that would be 4 square roots of 7 plus 4 square roots of 7, which would be 8 square roots of 7. Okay. And, you know, notice on that one, the first one had a square root of 7. So that second one, I'm trying to get it as 7 times something for me to be able to simplify. Part B is a little bit different because 32 and 18, we actually need to work with both of these. So 32, that would be 16 times 2. And 18 would be 9 times 2. Again, what we're trying to do is factor out some perfect squares. On 32, you might have looked at that and you might have said, oh, it's 4 times 8. That's fine, but then the next step you might notice, oh, 8, I could have done that as another 4 times 2. So just make sure you've broken it down all the way and that there's no other perfect squares still left that we can factor out of there. So square root of 16 is 4, square root of 9 is 3. And now we can subtract those, would be 8 square root of 2. In some problems, if we have a radical right next to a binomial, or if we have a binomial times a binomial, these are cases where we will want to distribute. So you can see on problem 3, part A, that they did that. They distributed that. And like here, we would just multiply the 10 times 6. That's the square root of 60. And then once we've multiplied them together, then you can try to break that apart. So 60 is divisible by 4, so that's square root of 4 times square root of 15. And notice on this one, when we get to the end here, there are different numbers under the radicals, and we don't have any perfect squares we can factor out to get those the same as each other. So we'll just leave it like that. That will be your simplified answer for that problem. Part B is a little bit more of a job just because we have to FOIL that out. We have to distribute both of these. When you do that, make sure you think of this as -2 times the square root of 3. And then what's going to happen here is you're going to have some middle terms that you can cancel, or you can combine rather. So that'd be like -1 square root of 18. You don't have to put the 1 there. And then just notice 18 square root of 18 we can factor out as square root of 9 times square root of 2. And then this part, what they did, the 6 minus 6 canceled. They're kind of doing two things at once here. And then square root of 9 is 3. So this is what they ended up with for that one. All right, so if we look at the got at 3, part A, we're just distributing that. So square root of 2 times square root of 6 plus square root of 2 times 5. So that'd be square root of 12. This one, go ahead and put the 5 in front of the square root just so it doesn't accidentally find its way underneath the radical or something. Square root of 12, we can do that as square root of 4 times the square root of 3. And then once we get to this point at the end, we have different numbers under the radicals, so that would be our final answer for that one. Part B, it's being squared, and so what you may want to do is actually just rewrite this times itself. If you square something, it's multiplied by itself. And so we do square root of 11 times square root of 11 plus square root of 11 times -2, or minus square root of 11 times 2 if you want. And then minus 2 times square root of 11 and minus 2 times -2. Square root of 11 times square root of 11, it's square root of 121 if you want. It's just going to end up being 11 because it's like the square root of 11 squared. And then if we simplify these middle terms usually will be able to be combined when you FOIL this out. So this is -4 or -4 square root of 11 and then +4. And then at this point, these numbers we can combine. 11 plus 4 is 15. So 15 minus 4 square root of 11. And then C is more of the same on part C. It's just, again, it's going to be a little bit of a mess here. It's like cleaning your house sometimes. It's a little bit of a mess, and then in the end, though, it kind of gets cleaned up, and then it looks nicer. So this is kind of a long problem to try to fit here all at once, so apologize, this is getting a little bit sloppy right now. So 4 square root of 18, again just multiplying the numbers under the radical here. Same thing on the second part. Here 2 times 4 is 8, and then under the radical 3 times 3 is square root of 9, and then minus 6 square root of 18. If you want to, if you notice these both have radical square root of 18s, if you want to combine those now you can. We'll actually be able to simplify them in a minute. Square root of 36 is 6, square root of 9 is 3. And then I'm going to kind of multitask here. Square root of 18, we can break that down as square root of 9 times square root of 2. And then square root of 9 is 3. 18 minus 24 is negative 6. So we've got this, which a lot of times when we do these, they're going to put the number first that doesn't have the radical in it, but either way is fine. These are equivalent answers here for part C. Right before problem 4, it talks about conjugates. Conjugates are the same except for their signs. One they're adding and one they're subtracting. Those are conjugates. So they give an example there. Square root of 7 plus square root of 3 and square root of 7 minus square root of 3. Those are conjugates. The reason we're interested in conjugates is that when we have a fraction, we want to rationalize it. Rationalize it, what does that mean? We want to get it where it doesn't have a square root in the denominator. We don't want square roots in our denominators. So what we can do to get rid of that, as long as you multiply the numerator and the denominator by the same thing, you're going to get an equivalent fraction. So on problem 4, if you look what they did here, they just multiplied by the conjugate. They've got square root of 7 minus square root of 2. So they just multiplied the numerator and the denominator by square root of 7 plus the square root of 2. When they did that in the numerator here, normally what I would probably do is go ahead and distribute that out. They didn't do that, which I guess makes sense. To just leave it at this point in case it can maybe cancel something out later. And then what's going to happen in the denominator, they didn't show all of this, but what's happening in the denominator, when we're foiling this out, you're going to get basically the middle terms are going to cancel out. Kind of like when we did a difference of squares earlier in the year. Okay, so this is square root of 49 plus square root of 14 minus square root of 14 minus square root of 4. So see this part? These are opposites that are just going to cancel. So we end up with 7 minus 2. Square root of 4 is 2. So 7 minus 2 is 5. So that's what the book did. They didn't show all that. They just said, oh, here it's 7 minus 2, and then that's 5. And then at that point, since the 10 is being multiplied by the quantity square root of 7 plus the square root of 2, that's a factor, and so we can reduce these. We can basically reduce the numerator and denominator by a factor of 5. So just reducing these. Okay, again, the only reason we can do that is because this is all in parentheses. It's being multiplied. And if you're not sure whether you can do that or not, the safer thing, if you want, would be to distribute the 10 in the numerator, and then individually you can divide each part out, and then you'll get the same answer here. And again, it's not a big difference there at the end, whether you have the 2 out in front of the parentheses or whether it's distributed. Those are probably either one should be okay for that. So if you look at the got at 4, in order to work this out, we don't want a radical, any square roots in the denominator, so we need to multiply by the conjugate. So we can go ahead and distribute that in the numerator. Negative times negative would be a positive there. And then in the denominator, if we're just foiling this out, and again, what's always going to happen, those middle terms every time are going to cancel out with each other. Okay, so I mean, if you want to go through this, minus square root of 50 plus square root of 50, but every time that's what's going to happen. So these will just cancel each other out. And then this will be 10 minus 5, which is 5. And then at that point, really there's nothing else we can do. And so you can just leave it like that. Yes, we could divide it out, but since it doesn't come out evenly, negative 3 divided by 5, 3 divided by 5, neither one comes out evenly. You can just leave it as one big fraction. The next part talks about golden rectangles, and here's the golden rectangle ratio. So fiddlehead ferns naturally grow in spirals that fit into golden rectangles. What is the width W of the fern shown? So this is a proportion ratio. So you can see from the picture, the one dimension here is 4. And we're trying to find W, which is the smaller dimension. Well, here it tells us ratio of length to the width. So length, this is the length, and this is the width. So when we set up our proportion here, the 2 is going to match up with our width. And the length, they told us, was 4. So this would be our proportion, and then it's solving the proportion. Solving the proportion, there's really not a nice pattern to this, so if you want to just cross multiply, you can do that. And then what they did is they said, well, it's W times this. I don't really want to multiply the W into that because that's just creating more W's, more W terms. So what they did is they said W is being multiplied by this thing. I'm going to divide by that thing. The only problem with that is by doing that, we have a square root in the denominator. So at that point, we would have to multiply by the conjugates. I like to have parentheses around these when I'm doing this. The book's not really seeming to care about that. But anyway, you would FOIL this out. They're not showing all the steps there, but basically, you know, after you simplify that, that's where you get the 1 minus 5, which is negative 4. And then since each of these is divisible by negative 4, that's what they're doing. Basically, 8 divided by negative 4 is negative 2. And then if you divide these, you get a negative divided by negative would be a positive. And then when you simplify this, you get about 2.5. So that would be about 2.5 centimeters. Again, didn't come out exactly, so they probably should have told us how to round that, but that would be an approximation for that one. So if we look at the lesson check, number 1, these are like terms, basically, that we can combine together. If you want to put a 1 in front of the second one, you can, and that would be 5 square root of 3. The second one, right now, there's nothing we can do. Square root of 24, we can break that up as the square root of 4 times the square root of 6. And then when you subtract, that's 1 square root of 6, or you could just say square root of 6 if you want. Number 3, we're going to distribute this. And square root of 21, we can't break that down at all, so that actually is going to be our final answer. Number 4, you can rewrite that times itself since it's being squared. And then we're going to just FOIL this out, distribute this out. This last part, both of these are negative, so negative times negative, that's going to be a positive 36. The middle terms we can combine. Square root of 25 is 5. And then 5 plus 36 is 41. So 41 minus 12 square root of 5 would be our final answer for that one. Number 5, we've got a square root in the denominator. So we need to multiply by the conjugate of that. Notice in the numerator that is a monomial. There's no addition or subtraction in between this. So it's literally just distributing that. When you do that, the 3, if you want to put that in front, you can, since it doesn't have a radical on it. And in the denominator, if we distribute, so 3 times 3 is 9. Middle terms are going to cancel. And then this will be minus square root of 4. So this will be 21 square root of 5 minus 7 square root of 10 all over. Square root of 4 is going to be 2, so 9 minus 2 is 7. At that point, both of these numbers in the numerator are divisible by 7, so we can actually divide these out. And then this will be 3 square root of 5 minus 1 square root of 10, or just 3 square root of 5 minus the square root of 10. And then number 6 is going to be a similar situation. So we would just multiply by the conjugate. And we can distribute in the numerator and the denominator. Once again, those middle terms are just going to cancel. Square root of 49 is 7. 7 minus 4 is 3. And these are both divisible. So again, if you wanted to wait to distribute in the numerator, you could have done that, I guess, because at this point both of these will be able to be divided out. Number 38 I wanted to go through because just to get practice on one of these again where it's got this proportion set up. So what we would want to do here is to cross multiply. There's only one variable, so don't distribute that. And then square root of 2 times square root of 2 would be the square root of 4. Square root of 4 is 2. So over here we got basically 5 times 2, which is 10. And then at that point, whatever they're multiplying by, we can divide by that. And then that would be our answer. You don't technically need to put parentheses around that denominator, but I like to just because it reminds me that unless I see another identical square root of 2 minus 1, there's nothing I can cancel with that. Your other option you could have done on this problem is you could have said that the x is being divided by the square root of 2, so you could multiply by the square root of 2 on both sides. But by doing that, if you'll notice, you would end up having to then multiply by the conjugate after that. So I don't know that it really saves a whole lot. I'm not a big fan sometimes, but sometimes cross multiplying is probably just the best way of doing the problem. So So this gives you an idea of how to work with operations with radical expressions.